Welcome to True Projects. In this video, we are going to explain about a project titled Real and Fake Face Detection using Deep Learning. This groundbreaking project aimed to develop a highly accurate and efficient system that can discern between genuine and synthetic facial images, leveraging the power of three state-of-art deep learning architectures: MobileNet V2, Inception V3, DenseNet. And our research endeavors to build a robust anti-spoof classifier capable of accurately detecting the manipulated faces. By training on a diverse dataset of real and fake facial images, this project seeks to enhance the security of the facial recognition system, protect the users from the potential cyber attacks and the fraudulent activities, and upload the integrity of the digital information in increasingly technological advanced world. The objective of this project is to develop a cutting-edge real and fake face detection system using the deep learning model, including MobileNet V2, Inception V3, and the DenseNet. By leveraging the power of these architectures, we aim to create a highly accurate anti-spoof classifier capable of distinguishing between the genuine and the manipulated facial images. Through the rigorous training on a diverse dataset of real and fake faces, our goal is to enhance the system robustness and generalization ability. The project seeks to provide a reliable defense against the rising threat of deep fakes and the manipulated images, safeguarding the integrity of the facial recognition system and ensuring the user privacy and the security. The success of this project will contribute significantly to bolstering the digital trust, preventing the cyber attacks, and promoting the responsible use of facial data in various domains. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, essential Python libraries are imported, including TensorFlow, Keras, NumPy, Pandas, and Flask. These libraries provide the necessary functionality for the deep learning, data handling, image processing, and using Flask. And the second one is loading the data. The dataset containing real and fake facial images is loaded into the project. Each image is associated with a label indicating whether it is a genuine or the manipulated face. And the next one is image scaling and processing. Before feeding the images into the deep learning model, they undergo the image pre-processing step, such as resizing and the normalization, to ensure the uniformity and better model convergence. This step enhances the image quality, reduce the computational complexity, and contribute to the improved detection accuracy. And the next step is splitting into the training and testing. The data set is split into the training and testing subset to train and evaluate the performance of deep learning model effectively. The training data is used to optimize the model parameter, while the test data assess the model's generalization ability. And the next one is building the model. Here, various state-of-art deep learning architectures are utilized to build the model. The first one is MobileNet V2. It is a lightweight and efficient deep learning model designed for mobile and embedded vision application. It is known for its compact size and low computational complexity, making it ideal for the deployment on resource-constrained devices. It utilizes the depth-wise separable convolution, which significantly reduces the number of parameters and operations while preserving the high accuracy. This architecture is well suited for the real-time image processing and of including the real and fake face detection. And the second one is Inception V3. Inception V3, also known as GoogleNet, is a powerful deep learning model that achieved the state-of-art result in the image classification task. It is characterized by its use of Inception module, which allow the network to learn the multi-scale feature by performing the convolution at the multiple kernel sizes simultaneously. Inception V3 is deeper and more complex than of MobileNet V2, making it suitable for more computationally intensive tasks. It is adept at capturing the intricate pattern and the complex relationship within the images, making it a strong candidate for the real and fake face detection, especially when dealing with the high resolution and the diverse facial data. And the third one is DenseNet. It is a unique deep learning architecture that facilitates the feature reuse and fosters the strong feature propagation throughout the network. To achieve this by connecting each layer to every other layer in a dense manner, DenseNet reduces the vanishing gradient problem, enabling more efficient and effective training. Its skip connection encourages the fusion of information from the different depths, promoting the better gradient flow and the feature extraction. DenseNet is particularly suitable for the task where fine-grained details and feature interactions are crucial, making it well suited to the real and fake face detection in scenarios with complex and subtle manipulation. And the next one is Anti-Spoof Classifier. It is a custom-built component responsible for the final classification decision. It takes the output of the three models and employs the ensemble technique, such as of voting or averaging, to make the final prediction. This ensemble approach enhances the overall detection performance by leveraging the strength of each individual deep learning model. And the next step is training the model. Once the deep learning models are constructed, they are trained and pre-processed training dataset. During the training, the models learn to recognize the distinguishing features between the real and fake faces, optimizing the parameters for the accurate classification. And the next step is user gives the input. A Flask-based web application is developed to allow the user to input the facial images directly. Here, users can upload the images through the web interface for the real and fake face detection. And the next step is the given input is pre-processed for prediction. When a user submits an image, the input image undergoes the same pre-processing step as of the training image. This ensures the consistency and the compatibility with the deep learning model required for the prediction. And the next step is trained model is used for the prediction. The pre-processed input image is passed through the MobileNet v2, Inception v3 and DenseNet. Their outputs are then fed to the anti-spoof classifier, which makes the final prediction decision based on the ensemble technique. And the last one is final outcome is displayed. The model's prediction result, whether the input image is real or fake, is presented to the user through the web application. The output provides the crucial insights of the submitted image, offering a powerful defense against the potential deepfake threat. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The real and fake folder containing of the training of fake and real images within it. And the static folder containing of the folders like CSS, JavaScript, images, uploads within it. And the template folder containing of the HTML documents, it typically include home, index, notebook, result, sign in and sign up pages within it. An app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the uploads folder containing of the various images within which will be used for testing the performance of the model. And these are the H5 files which contain the information of algorithm, and it is loaded into the project code during the runtime to utilize the trained model for the various tasks such as making the prediction on the new data or performing the specific operations. An IPYNB file name or notebook contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. And write a command cd space and paste this code folder path. By this, it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this address and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it will redirect it to this page contain of title, sign up and sign up buttons. And click on the sign up button. Here it will redirect it to this page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the login page containing of username and password that need to be filled. And then click on the login button. Here it will redirect it to this index file containing of the choose file and upload buttons. And then click on the choose file button. It will redirect it to this folder containing of images within it. I'm selecting one image and then click on the open button and then click on the upload button. Here it will redirect it to this result file and be predicted as uploaded image is of real type. And then by using the try again button, here it will redirect it to this index file, and here by clicking on the choose file button we can upload the other image too. And then clicking on the choose file button, here it will redirect it to this folder and of selecting the one image and then click on the open button and then click on the upload button. Here it will redirect it to the result page and predicted that image is of fake. In this way we can predict the real and fake images by using the deep learning algorithms. And in conclusion, our project successfully achieved its objective of implementing a robust and real fake face detection using the deep learning model, including the MobileNet v2, Inception v3 and the TenseNet. The developed anti-spoof classifier demonstrated the remarkable accuracy in distinguishing between the genuine and manipulated facial images, providing an effective defense against the deep fake threats. By training on a diverse data set, we enhanced the system reliability, making it suitable for the various applications from the facial recognition, security to combating the cyber attack and the fraudulent activities. This project's success contributes significantly to strengthening the digital trust and ensures a safer and more secure digital landscape for the users in an increasingly technological advanced world.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.